So for number 6, we have that A and B are real numbers. That's what we're assuming, and we want to prove all these things. So because we're proving things with the absolute value, I've gone ahead and I've put this definition here that for all x belonging to the reals, the absolute value of x is x if x is non-negative, and minus x if x is negative. So I'm not going to cite this in every single case. I'm just going to leave it here for all of these problems. However, if you're doing these individually, then you should definitely cite this definition. So for A, we want to prove that the absolute value of AB is equal to the absolute value of A times absolute value of B. So because the absolute value is different when the numbers are positive or negative, we do have to consider the different cases. So we're going to go case 1, where we have here that A is greater than 0 and B is less than 0 without loss of generality. The loss of generality. So this without loss of generality just means that I can consider the case where A is positive and B is negative, or where A is negative and B is positive, because we aren't assuming anything about A and B other than they have opposite signs. The logic still applies in the opposite case. So we don't also have to prove, the case where A is negative and B is positive. So in this case, we have that the product AB is less than 0. And so the absolute value of AB, because this is negative, it's going to be minus AB. Okay. And then we have that the absolute value of A is just equal to A because it is positive, and the absolute value of B is going to be equal to minus B. And so the absolute value of A times the absolute value of B is going to be equal to minus AB, because that's minus B times A, right? And so here we can see that in both cases, we have therefore, because both of them are equal to minus AB, we have that the absolute value of product AB is equal to A times the absolute value of B. So that was the first case where they have opposite signs. Now let's consider case 2 where they are both positive. So in this case, product AB is going to be greater than 0, and so product AB is just AB. And then absolute value of A is just A, absolute value of B is just B, and so absolute value of A times absolute value of B is equal to AB. And so we've shown that they're equal the same thing, so we can say that, so therefore, the absolute value AB is equal to A absolute value of A times absolute value of B. Okay, so we've shown case 2. We need case 3, and maybe I'm going to do that to the side. So we have here case 3, and case 3 is where they're both negative. So A is less than 0 and B is less than 0. So product AB, because we're going to have two negatives, that product is going to be positive, and so the absolute value of the product is just going to be AB. But then we have that the absolute value of A is just minus A. The absolute value of B is minus B. And so the absolute value of A times the absolute value of B is minus A times minus B, which is also equal to AB. And so we have shown that they are the same. And so we're going to say, therefore, absolute value of AB is equal to absolute value of A times absolute value of B. And the last case, so we have a case 4, we have to consider when one of them are 0, right? One or both. So in this case 4, we have that A is equal to 0 or B is equal to 0. And so we have that in this case, AB is going to be equal to 0 because when one product is 0, the whole result is 0, and therefore the absolute value of A times the absolute value of B is also going to be equal to 0, and so AB is equal to absolute value of A times absolute value of B. So we've shown here that in every possible case, in the case where they have opposite signs, where they're both positive, where they're both negative, or when one of them, at least one is 0, we can see that in both cases, not both, in all cases, we have proven what we wanted, which is that absolute value of AB is equal to absolute value of A times absolute value of B. Okay, so that was item A. Now we're going to do item B. So let me erase this. Okay, so for item B, what do we want? We want to show that the absolute value of A minus B is equal to the absolute value of B minus A. Now this one is a bit tricky because we do have to consider several cases. Well, I guess no more tricky than the previous one. So for this one, we're going to have, for item B, we want to first consider the case, because we're talking about the difference, we want to know whether the difference is it's positive, right? So we're going to consider the case 1 is going to be when A is bigger than B. So in this case, when A is bigger than B, it means that A minus B is going to be greater than 0, and B minus A is going to be less than 0. So we have that absolute value of A minus B, since this is positive, is just going to be equal to A minus B. And the absolute value of B minus A, since this is negative, it's going to be or B minus A is negative, right? It's going to be minus B minus A, which is equal to, when we distribute this negative, minus B plus A, which is equal to A minus B. And so we have shown, thus A minus B, the absolute value is equal to the absolute value of B minus A. Okay, so case 2 is the opposite situation, is when A is less than B. So when A is less than B, we have that A minus B is going to be less than 0, and B minus A, it's going to be, and B minus A is going to be greater than 0. So the absolute value of A minus B, since that is less than 0, this is going to be minus A minus B, which is the same thing. When I distribute that minus, we're going to have minus A plus B, or B minus A. Okay, and then the absolute value of B minus A, because this expression here is positive, it's just going to be the same thing. And so we have shown that they're equal to the same thing, right? And so thus the absolute value of A minus B is equal to the absolute value of B minus A. So the one can either be bigger or smaller than the other, or case 3 is when they're equal. So is when we have that A is equal to B. And when this happens, it's pretty easy, because A minus B is going to be equal to 0, and B minus A is going to be equal to 0. So the absolute value of A minus B is going to be equal to 0. The absolute value of B minus A is also going to be equal to 0. Thus, they are the same. A minus B. Okay. And so we have shown in every possible case that what we wanted to prove is true. So that's it for item B. Now let's do item C. So item C, we want to prove that the absolute value of A over B is equal to the absolute value of A divided by the absolute value of B, providing that B is not equal to 0. So once more, we have to consider the cases where they're negative or positive, right? So we're going to say that case 1, and that changes to C. Case 1 is where A is positive and B is negative without loss of generality, just as we did in A. So we're going to say that A is positive and B is negative without loss of generality. And once more, this just means that because we don't assume anything about A and B, if we prove that it's true in this case, then it is also true where A is negative and B is positive. The reasoning is the same. So if we have here that A is positive and B is negative, then when we divide them, when we go A divided by B, well, that's going to be negative, right? Because we have a positive over a negative. So because this is going to be negative, the absolute value of A over B is going to be equal to minus A over B, because that thing was negative to begin with, right? And so we have shown this. Now let's go to absolute value of A, which is just A because it's positive. Absolute value of B is negative B. And so we have that the absolute value of A divided by the absolute value of B, well, this is going to be equal to A divided by minus B, which is the same thing as minus A over B. And so we've shown that it is true, right, that both of these absolute values are equal the same thing. And so thus, absolute value of A divided by B is equal to the absolute value of A divided by absolute value of B. So that was case one. Now we have to deal, which is the case where they have opposite signs without loss of generality. Now we have to deal with case 2. And in case 2 is where they're both negative. So A is less than 0, B is less than 0. So in this case, their quotient, A over B, that's going to be positive because we're dividing two negative numbers. And so absolute value of A over B, well, that is going to give us just A over B because that quotient is positive. And so absolute value of A is going to be minus A because A is negative. Absolute value of B is going to be minus B because it's negative 2. And so absolute value of A divided by absolute value of B is going to be minus A divided by minus B, which is A over B. And so once more, we have shown that the absolute value of their quotients is equal to the absolute value of each one, and then we divide them. Okay, and then we have the case 3. So case 3, actually I'm going to do that to the side. So for case 3, we're going to have that A is positive and B is positive. So in this case, we have that the quotient is going to be positive, and so this absolute value is going to be just A divided by B. Okay, absolute value of A is just A, absolute value of B is just B, and so we have that absolute value of A divided by absolute value of B is just A over B. So these are clearly the same, and thus we have shown what we wanted, which is equal to absolute value of A divided by absolute value of B. And lastly, we want to deal with the case, because we've shown where they're both negative, both positive, where they have different signs. And the last case is where A is equal to 0. Remember that B can't be equal to 0. So case 4, where A is equal to 0. So in this case, we have that A divided by B is 0. And so absolute value of A over B is going to be equal to 0. And then we have that the absolute value of A is 0, so the absolute value of A divided by the absolute value of B, that is also going to be 0. And so in this case, it is very obvious to see, thus this absolute value is equal to that. And so we have shown that it is true for all cases. Okay, so that was item C. That was pretty straightforward. And now let's do item D. I think that item D possibly will be the most complicated one. So let's go ahead and do that. So item D is going to be, we want to prove that the absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. And so for this one, let's see. we're going to have that. For D, once more, we're gonna show the different cases depending on whether they are positive or negative, right? And so we're gonna have case 1 where A is less than 0 and B is greater than or equal to 0. And in this case, we're showing without loss of generality. So this case, we do need a subcase, because even though they have opposite signs, we don't know whether the sum is going to be positive or negative, right? It could be that A is like minus 10 and B is 1. So, or it could be that A is minus 1 and B is 10. So we have to find out whether the sum is positive or negative. So I'm going to put a subcase, right? So we're going to have case 1.1, so a subcase where we're going to have that A plus B, the sum is negative, right? And so in this subcase, we have that A plus B, the absolute value, because it's negative, it's just going to give us minus A plus B, which is minus A minus B, okay? And then we have that the absolute value of A is going to be equal to minus A because it's negative, and the absolute value of B is just going to be equal to B because it's positive. And also we have that B is greater than or equal to 0, right? So what we have here is that minus A minus B is definitely going to be less than or equal to minus A plus B, right? And so we can see here from this inequality that if we just take a look at it, we can see that actually I should have shown no, I think that this still works. And so we can show that on the left-hand side, absolute value of A plus B is equal to, this is the absolute value of A, sorry, not equal to, less than or equal to, plus the absolute value of B. We have shown what we wanted to show, right? And the whole point here is that this guy is over here is the absolute value of A plus B. And then we have that these two here are the absolute value of A and the absolute value of B. Okay, so that was case 1.1. And now we have to do case 1.2. So still the subcase, right, where A is negative, B is non-negative, but now we're going to consider that this sum is greater than 0. So in this subcase, we have that the absolute value of A plus B, well, this is just going to be A plus B, no big deal, right? And then we have that the absolute value of A is going to be equal to minus A, and the absolute value of B is going to be equal to just B. And so we have that A is less than 0, right? So A plus B is less than or equal to minus A plus B. Because if A is negative, minus A is going to be positive. So this is definitely true. And therefore, we can say that the absolute value of A plus B is less than or equal to the absolute value of A plus absolute value of B. And so once more, I am just going to highlight that these are equal. These here are equal, right? So that is equal to that, and that is equal to that. Okay, so we have dealt with case 1, which is when the signs are opposite without loss of generality. But now we have to deal with the case where they're both negative. So we have case 2 where A is negative and B is negative. So when A is negative and B is negative, clearly their sum, A plus B, is going to be negative. So the absolute value of A plus B, this is going to be equal to minus A plus B, which is minus A minus B. And so absolute value of A is equal to minus A, absolute value of B is equal to minus B. And so in this case, we can say that it is true that minus A minus B is less than or equal to minus A minus B because of the equal sign. And so we can say that the absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. And once more, if we're going to highlight this, we're just going to show that this guy is this guy right here, and then this guy is going to be this one, and this one is also going to be this one. Okay, so you guys can follow that by color coding. We have dealt with the case where they're both negative. Now let's deal with the case where they're both positive, right? So, and then we have that case 3, a is greater than or equal to 0, b is greater than or equal to 0. And this is the easiest one because now their sum is positive. And so what we have here is that absolute value of a plus b is just a plus b, and then absolute value of a is just a, absolute value of b is just b. And so we have here that a plus b is less than or equal to a plus b, and so that is the absolute value of a plus b less than or equal to absolute value of a plus absolute value of b. Okay, so we have shown here that it is true when they have opposite signs. When they have opposite signs, their sum could be positive or negative. I guess I should have added here. Yeah, and we have shown the case where they're both negative and where they're both positive. So that is it for item D. And now let's move on to the last two cases. This is turning out to be quite a long problem, but we can do it. So for item E, we have that if absolute value of A is less than or equal to B, then this guy right here. So we're going to begin by assuming our hypothesis. So for item E, we're going to say assume that the absolute value of A is less than or equal to B. So because the absolute value can't be negative, this implies, I'm going to say, so this implies that this implies that 0 is less than or equal to absolute value of A, which is less than or equal to B, just because the definition of absolute value doesn't let it be negative, right? So we have to consider just two cases here. So case 1 is when A is greater than or equal to 0. So if A is non-negative, it means that the absolute value of A is just A, right? And if the absolute value of A is just A, it means that B is greater than or equal to A, because B is greater than or equal to the absolute value of A, so definitely, which is the same thing as A, right? And is greater than or equal to 0. So once we have this, we can just include, okay, B is positive, so this still holds. But then, because B is positive, it means that 0 is greater than minus B, right? And so once we have established this, we can say, therefore, B is greater than or equal to A, which is greater than or equal to minus B. So we just remove the 0, right? And so we have shown that this is true. And now let's do case 2. So case 2, we're going to have where A is less than 0. So where case A is less than 0, we're going to have that the absolute value of A is going to be equal to minus A. And we have that minus A is less than or equal to B because the absolute value of A is less than or equal to B. And so this implies that if we subtract B and add A to both sides, so I'm going to go minus A plus A minus B is less than or equal to B plus A minus B. So all I've done is I've added A minus B to both sides. So we have here, this implies that on the left-hand side, the A's are going to cancel out. So that's going to be equal to minus B. And on the right-hand side, the B's are going to cancel out. So this implies that A is greater than minus B. However, A is negative, right? So if A is negative, then minus A is greater than A. And so once we've established these three things, and I'm going to highlight them, once we've established this, and that, what we're going to do here is we're going to stack them in the order at which they're bigger. So the biggest one is B, which is greater than or equal to minus A, right? Which is greater than or equal to A, which is greater than or equal to minus B. And so, therefore, we're just going to cut out the A. Therefore, we can say that B is greater than A, which is greater than equal to negative B. And so we have shown here that in both cases, our conclusion is true. And for item F, we want to work backwards. We want to begin with our conclusion and then conclude the hypothesis. So for item F, here, we're going to assume that minus B is greater than or equal to A, which is, less than or equal to A, which is less than or equal to B. So once more, we're going to break it down by two cases. So case one, we're going to have where A is greater than or equal to 0. So when A is greater than or equal to 0, the absolute value of A is just equal to A, right? And so if the absolute value of A is just equal to A, it means that absolute value of A is less than or equal to B, which is greater than or equal to negative B. Therefore, absolute value of A is less than or equal to B. So I've just kept the right-hand side of my inequality, and I have proved that. And for case 2, where A is less than 0, we're going to have here that if A is less than 0, it means that B, actually I'm going to, absolute value of A is equal to minus A. And so B is greater than or equal to minus A. So once I have this, what I'm going to do here is I'm going to just to add minus A to both sides, right? Let me see if that is correct. B is greater than or equal to minus A. I feel like there is something wrong. No, I should have skipped this step actually. Case 2, A is less than 0. Okay, so in the case where A is less than 0, it means that B is greater than or equal to A, right? Because this implies that let me move this. B is greater than or equal to A. So in this case here, what we're going to do is saying, okay, then A is going to be greater than or equal to minus B, right? And so if A is greater than or equal to minus B, what I'm going to do is subtract A from both sides. So I have here that So I have that minus B minus A is less than or equal to A minus A. And so in this case, A minus A cancels out, right? I have that minus B minus A is less than or equal to 0. And then I'm just going to bring the B to the other side. So I have that minus A is less than or equal to B. And so this implies that B is greater than or equal to the absolute value of A because A is negative, right? And so in this case, I'm just going to say that the absolute value of A is equal to minus A. And so therefore, absolute value of A is less than or equal to B. And so in both cases, we have proved our conclusion, which we wanted to. And that is it for item 6.